In this video, we are going to look at Lewis or electron dot structures. Lewis and electron dot structures are the same thing. Lewis and electron dot structures correspond to the spotlight here, covalent molecules. So covalent molecules are between two nonmetals. So we go to our line here, and remember, we eliminate the noble gases. So it's going to be really about 10, 12 elements that are going to be involved in all of these electron dot structures. Remember, we are also going to include hydrogen. You're thinking, how many molecules can be made up with these so few? But really, all of our hydrocarbon fuels, our plastics, our proteins, our sugars, our fats, and water are all made up with this. So there are a lot of things with these covalent molecules that we're going to be learning about. Okay, and we're primarily, let's go look at a diagram that I think we've showed before. So this is water, or H2O. So oxygen has 8 protons. It has 2 electrons in the first shell and 2, 4, 5, 6 in the next shell. It wants to get 2 more electrons. What's it going to do? It's going to share with a hydrogen, which has 1 electron and wants to get to 2. And it's going to do that with another hydrogen and do the same thing. So this oxygen gains 1 electron by sharing with this one and 1 more electron by sharing with this one. And this hydrogen gains an electron by sharing with the oxygen, and this hydrogen gains an electron by sharing with the oxygen. Look at this structure. Electron dot structures are much the same as this, except it's only concerned with the outer shell electrons, like these two, and these two, and these two, but not the inner shell. So it's a simplified version of some of these things that we have done before. All right, so let's take a look. We are going to actually start with the example of water, and we're going to follow some rules that we have, and we'll refer back to those up here. So the first thing it says is add the number of valence electrons, that's the outer shell electrons, in that we have, okay? So hydrogen has 1 valence electron, or 1 electron, for a total of 2 electrons, because there's 2 of them, and oxygen has 6 valence electrons. Valence electrons are the electrons in the outer energy level, excluding filled b or f orbitals, and that would actually mean the same as a family number. So this family will have 1, this family will have 2, including hydrogen. Okay, this family, including hydrogen, having 1. This would have 3, this would have 4, this would have 5, this would have 6, this would have 7, and we're not going to be working with the noble gases here. Okay, so that is where we're looking at oxygens in family 6A, so we're going to say that has 6 valence outer shell electrons. Okay, looking at this structure, we can see 1, 2, 3, 4, 5, 6 in its outer shell. All right, so we get to that. And the next thing says, put electrons around each atom. Start with the 4 base electrons before pairing up. It's best to start with the atom with the fewest electrons. So the atom closest to the middle of the table, excluding hydrogen. Hydrogen always goes last or on the ends. So I'm going to start with oxygen, okay? And I'm going to go and I'm going to do, oxygen has 6 valence electrons, and I'm going to do 1 and 2. I'm going to do another one, and 3 and 4, and then I start pairing up. So I go 1, 2, 3, 4, then start pairing up. 5 and 6. Okay, now I look, it's supposed to have 8 around it. Everything wants to get to 8 electrons. So atoms bond when electrons are needed to be shared complete in octet. The only exception is hydrogen, which wants to get to 2. So let's go change our color here and do this. And, oh, I still need 2 more electrons on this structure, and each hydrogen has 1 electron. So I'm going to put a hydrogen here. I'm going to put a thing here. I'm going to put an H right here. And I'm going to do the same thing. I'm going to put one here, and I'm going to put an H right here. And now I'm going to look at this. It says the total number in the Lewis structure should equal the total number of valence electrons in the molecule. So I'm supposed to have 8. I have 2, 4, 6, 8. I have 8 around the oxygen, which is what I should have. I have 2 around each hydrogen, which is what I should have. So this is the electron dot structure for it. Notice it's similar to what we had before, except I don't have the interior electron. So it's not, what happens is I don't have the interior electrons. When I'm talking about this electron pair, and then the two bonds to hydrogen. So there is another question here, is where do I put these electrons? Do they have to go across from or right here? And what happens is, this is based off a tetrahedral shape. So if I take any two places off and just have an electron pair there, and this is what we'd have, this is a structure that we're going to have. It's going to be a bent structure. In a tetrahedron, there are really no across froms in that. Okay, so looking at this, it's pretty easy to see this, except the bond angle isn't quite 90 degrees. It's bigger because it's in a three-dimensional, they're spread out further because the whole thing is in a three-dimensional structure. There's a couple electron pairs on here taking up spots in this structure right there. What if I would have drawn it like this? You could draw it like this with the O in the middle, and I'm going to put an electron pair here, and an electron pair here, and an electron pair here, and an electron pair here. I cheat a little bit. If I have two dots, it can also be considered a line. So I'm going to put a hydrogen here up above. So the two dots are line is the same thing. And there's a hydrogen. And then I put two dots and a hydrogen down here. Is this right here, when it's drawn, when the hydrogens are opposite, the same as this? Yes, you can think of it being set like this, and the hydrogens are just coming out of the board at you. So if the hydrogens are coming out at the board, then you could think, okay, this one's kind of flat, or these two hydrogens are kind of coming out at the board, and thinking of it in 3D, then it would matches up. Lewis structure is only concerned with what's connected with what. So I have the two hydrogens connected to the oxygen and the two unbonded electron pairs. Both of these structures are perfectly fine. So I'll put a one or the other is perfectly good. Okay. So that is our first example of a Lewis structure that we have. Okay, I'm going to go to another example. I'm going to have to clear this in order to do it, I think. Let me go here and try another example. Okay, I'm going to go to CF4. I'm going to just hide this down here. So carbon is in family 4. It has 4 valence electrons. So I went to my periodic table. I can go up there and see, oh, carbon's in family 4. It has 4 valence electrons. All right. And fluorine is in family 7, so it has 7 valence electrons. How do I know that? Fluorine is in family 7A, so it has 7 valence electrons. So I'm going to count valence electrons, and I'm going to get to, let's see, 4 for one carbon, and then 4 times 7, 28 for all the fluorines right there. Okay, so what I'm going to do is go back to my rules. And the first thing says is start with the one that will bond the most times, or the one closest to the middle of the table, and that's the carbon. So I'm going to put the carbon in the center. I think I'm just going to do that right here. Carbon's in the center, and it has, and then it says do 1, 2, 3, 4 before starting to double up. And then what I'm going to do is add fluorines. So I'm going to add the fluorines. And notice fluorine has 1. I'll put a fluorine right here. And it has, I'll do 1 where it's bonded. And then 2, 3, 4. Well, I got to get to 7. So I'm going to start pairing these up. 5. Kind of running out of room here. 6, 7. So I like to have these electrons go in pairs. And that matches up. So now I got 2, 4, 6, 7 from the fluorine. Notice with the bond, it now has 8 around it. Well, I'm going to do the same thing with all the fluorines. Okay, I'm going to come around here and add the electrons. 1, 2, 2. And they're going to be a little sloppy how I draw them. So I'm going to try to go fast. Sorry, that was a really sloppy electron in this right here. And then I'm going to keep going. And 1, 2, 3, 4, 5, 6, 7 for this fluorine. And then I'll do the same thing. And I'll go here, 1, 2, 3, 4, and then 5. I'll start pairing up 6 and 7 right here. That's going to be with this one here. Okay, so I look here and I have 2, 4, 6, 8, 12, or 16, 24, 32 total electrons. I'm going to draw a line that separates this bottom one from what we have here. And I have 8 around this fluorine, 8 here, 8 here, and 8 here. And the carbon gained 4 by combining with 4 fluorines. So now it has a full octet too. So this matches up. Everything has an octet. It's a full structure. The carbon needed to gain 4. It bonded with 4 fluorines. Each fluorine needed to gain 1. It combined with 1 oxygen. Okay, the last one I'm going to look at is OH minus. And I'm going to just scroll down to that briefly. This is actually on the next page. We're looking at pages 4 and 5. And what do you do when you get a negative charge? So I think I'm going to get rid of some of this right here. You clear this out. And I'm going to do my 6 oxygens. And I'm just going to go up to my rules. If you have add 1 electron for each unit of negative charge, for cations, subtract a 1 electron for each unit of positive charge. So if I have an extra negative charge, I mean, I get to add an electron to my structure. So I'm going to do that. And I have 6 for oxygen, 1 for hydrogen, and the -1 charge gives me an extra electron. So I'm going to do my oxygen, and I'm going to draw that and say 1, 2, 3, 4, 5, 6. Okay, now I'm going to draw in my, change my color here. I'm going to draw in my hydrogen, 1 electron there, and put that bond here. And I have 1 extra electron. Where do I need an electron? You can look where it's convenient. 2, 4, 6, 7. Oh, I need to put it right here. So I'm going to put it right there. And what will happen is this whole thing will act as one big molecule like this and just carry a -1 charge. It would probably look like this water molecule. I take just an H plus off of it. I'm left with this, and there's other unbonded electron pairs there around it too. Okay, so that would be one with a negative charge. All right, try these electron dot structures on pages 4 and 5 of your homework packet. Check the key to see how you are doing. Thank you.